We now find the derivative of h of x using the product rule and chain rule. So here is the product rule which says that the derivative of f of x times g of x equals f of x times the derivative of g of x plus g of x times the derivative of f of x. So we'll be utilizing this product rule and the chain rule to find the derivative of h of x. First, let's write this h of x in product form. So I write h of x equals 4x minus 4 raised to the power of 5, and this denominator can be written as times of 2x minus 5 raised to the power of negative 7. So now this is in product form so that we can apply the product rule. So let's consider the first function as f of x, and then the second function as g of x. And so when we apply the formula of product rule, we write h prime of x, which is the derivative of h of x, and this equals, we write the f of x now. So it is 4x minus 4 raised to the power of 5 times we find the derivative of g of x. So I write this as d by dx of 2x minus 5 raised to the power of negative 7 plus we now write g of x, that is 2x minus 5 raised to the power of negative 7 times the derivative of the first function, that is d by dx of 4x minus 4, and this is raised to the power of 5. So let's find the derivatives. That is on the left we have h prime of x, and this equals, I write the first term, that is 4x minus 4 raised to the power of 5, and we find the derivative of 2x minus 5 raised to the power of negative 7. We can use the power rule to find the derivative. So when we use the power rule, we put the power negative 7 and then put the expression 2x minus 5, and this is raised to the power of negative 7 negative 1, which equals negative 8. And then now we have to apply the chain rule to find the derivative of 2x minus 5. The derivative of 2x minus 5, and this equals the derivative of 2x, which is 2, and the derivative of negative 5 is constant, which is 0. So it's basically 2. So we multiply with this number 2. Now let's continue. Plus we write this 2x minus 5 raised to the power of negative 7, and we write the derivative of 4x minus 5, 4 raised to the power of 5 using the power rule. So I put the power 5 in front and write down 4x minus 4 raised to the power of 5 minus 1, which is 4. And now we have to apply the chain rule to write the derivative of 4x minus 4. The derivative of 4x minus 4 equals the derivative of 4x, which is 4, and the derivative of negative 4 is 0. So it's just 4. So we put this number 4. Let's continue. So we have h prime of x, and this equals, we will multiply the numbers, that is negative 7 times 2 is negative 14. So I put negative 14 times of 4x minus 5, this is raised to the power of 5, and we write down the negative powers of the expression as positive powers by writing them in the denominator. So this can be written as 1 over 2x minus 5 raised to the power of positive 8. Now let's write the second term. Here we have 2x minus 5 raised to the power of negative 7. This can be written as 1 over 2x minus 5 raised to the power of positive 7, multiplied with, we have this 5 as well as 4. So 5 times 4 is 20 times of 4x minus 4 raised to the power of 4. And so let's put this in appropriate fraction form. So we have h prime of x, and this equals, in the numerator we have negative 14, 4x minus, this is basically 4, it is not 5, minus 4 raised to the power of 5, and in the denominator we have 2x minus 5 power 8, plus the next fraction is we have 20 times of 4x minus 4, raised to the power of 4 divided by 2x minus 5 raised to the power of 7. Now we can combine these two fractions. The denominator of the first fraction is 2x minus 5 raised to the power of 8, and the denominator of the second fraction is 2x minus 5 raised to the power of 7. So to make it common denominator, we multiply and divide the second fraction by 2x minus 5 and divide by the same expression 2x minus 5. And so when we do that, can write this in the next step. We have h prime of x, and this equals negative 14 times 4x minus 4 raised to the power of 5 divided by 2x minus 5 raised to the power of 8 plus I put this 20 times of 4x minus 4 raised to the power of 4, and then we have this factor 2x minus 5, and this is divided by these two will combine, and it will be 2x minus 5 raised to the power of the adding the powers, we get 8. So now we see that we have a common denominator, and this means we can write this as a single fraction. So I write h prime of x, and this equals the first term is negative 14 4x minus 4 raised to the power of 5, plus the second term is 20 times 4x minus 4 raised to the power of 4 times 2x minus 5, and this is all over the common denominator, that is 2x minus 5 raised to the power of 8. Now if you look at the numerator expression, we have the terms of 4x minus 4 raised to the power of 5, and here we have 4x minus 4 raised to the power of 4. So therefore the GCF is 4x minus 4 raised to the power of 4, which I'm going to factor out. And so when we do that, we get h prime of x, and this equals, I'm factoring the term 4x minus 4 raised to the power of 4. Now I put this bracket. So when we factor 4x minus 4 raised to the power of 4 from this first term, we'll be left with one factor of 4x minus 4 multiplied with negative 14. And in the second term, we'll be just left with these two terms, that is 20 times of 2x minus 5. And this is all over 2x minus 5 raised to the power of 8. Let's continue. So we have h prime of x. This equals, in fact, I can factor 4 from this inside expression of 4x minus 4. So when I do that, I get 4 times of x minus 1, and this is raised to the power of 4. And let's simplify the terms inside the bracket. So we distribute this negative 14. Negative 14 times 4x is negative 56x, and this is negative 4 and not negative 14. So negative 4 times negative 14 is positive 56x. Sorry, it is positive 56. Now we multiply this 20 times 2x is 40x, and then 20 times negative 5 is negative 100, and this is over 2x minus 5 raised to the power of 8. Let's continue. So here we have h prime of x, and so this equals, in fact we can now apply the exponent laws to expand this. So here this will be 4 raised to the power of 4 times x minus 1 raised to the power of 4. Now let's simplify the terms inside the bracket. These two are like terms, that is negative 56x plus 40x. These two combine and give negative 16x, and 56 minus 100. These two combine and give negative 44. And this is all over 2x minus 5 raised to the power of 8. So let's continue simplifying this, and this equals 4 power 4 is basically 256, and we have x minus 1 raised to the power of 4. Now we can factor negative 4 from these two terms. That is, when we do that, I put this negative 4 times of, when you factor negative 4 from negative 16x, we will have 4x plus, when we factor negative 4 from negative 44, is basically we have to divide negative 44 by negative 4. So this gives positive 11. So it is 4x plus 11, and this is over 2x minus 5 raised to the power of 8. Now we see that we can combine this number and this number. We multiply them together, and so we get h prime of x, and this equals 256 times negative 4 equals negative 1024. And then we have the factor x minus 1 raised to the power of 4, and then we have the last factor 4x plus 11, and this is all over 2x minus 5 raised to the power of 8. And so this is the derivative of h of x in simplified factored form.